So, good morning, everybody. I want to go through and solve a few triangles completely using trig, Pythagorean theorem, and the fact that all triangles add up to 180 degrees total on the inside. This is going to be for our last kind of quiz that we're going to have coming up here. Every single triangle will be a right triangle, so you won't have to worry about next week when we start learning the law of sines and the law of cosines. That's not going to be on this quiz that I'm going to give you guys tomorrow. But you will certainly have to figure out all the different bits of a right triangle, where I only give you two additional things, including the fact that it's a right triangle. Every triangle can be solved with three parts, and in this case, 2 parts plus a right angle. So I'm just going to make up some examples here and go through some different ways that you can think about how to solve them. And what it really boils down to is trig, Pythagorean theorem, and the sum of all angles is 180. And not only that, but those last two, the Pythagorean theorem and the sum of the angles being 180, you don't even actually need those. You could do trig for every single piece of the triangle. It's up to you. I know some people, myself included, given 2 angles, I might like to just add things together to get up to 180 rather than do another set of trig to figure out what that last angle might be. Or knowing that I have 2 sides already solved, it might be easier to use the Pythagorean theorem to solve for that third side as opposed to trig. Although that one I think I might prefer the trig, to be honest with you. So let's just make some up and let's take a look at what I might be expected to do tomorrow or the next day or whenever you decide to take this quiz, because I'm giving you quite a while to do it. Alright, so here is a right triangle. Let's say that I give you 2 sides to this triangle. Or, yeah, why not? 2 sides to this triangle. I'm going to give you this side over here. Let's say that this is 10. And I'll give you the hypotenuse as well. Let's make this 14. These are the 2 things that I've given you now. And that means I want 3 other things. I need the angle up here, let's call it A. I need the angle down here, let's call it B. And I need the side down here, let's call it C. These are the 3 missing pieces in the triangle. And what you're going to see on the test is I'll show you the triangle, and one will be a multiple choice question that says, hey, tell me what A is. And then the same triangle, and it'll say, hey, tell me what B is. And then the same triangle again, and it'll say, hey, tell me what C is. 3 separate multiple choice questions for this whole thing, just because I don't know why. It's just the best way I have to do it while we're here. So let's figure out what we can do here. There's a lot of freedom with this, a lot of freedom. So really, what it amounts to is pick one. Just pick the thing that you want to solve for first and go from there. I'm going to start with A. Why not? So let me grab my blue marker here. I'm going to circle A. This is what I'm looking at. Based on the angle that I'm looking at, I want to know what these sides are. So the 14, fairly obvious, this is my hypotenuse, no matter what angle I'm looking at. That's my hypotenuse. But the 10, when I'm looking at angle A, the 10 is adjacent to A. I hope you see that. Adjacent. So, if I have the adjacent and I have the hypotenuse, what trig function might I be able to use? This is where we need to start remembering so, ka, toa. Remember that sine of an angle is equal to the opposite over the hypotenuse. Cosine of an angle is equal to the adjacent over the hypotenuse. And the tangent of an angle is equal to the opposite over adjacent. So, I've got adjacent and hypotenuse. Adjacent and a hypotenuse goes with the cosine. In this case, I want the angle. The angle is the thing that I want. So this is just like the assignment that I gave you at the beginning of the week, where now we want to use the inverse. The way to get the theta out of this thing is to undo the cosine. So do the inverse. So if I want A, it's going to be the inverse cosine of the ratio that I know the cosine to be. So that would be 10 over 14. The inverse cosine of 10 over 14. Let's see what we get. So cosine inverse of 10 divided by 14, close off those parentheses, 44.42 when you round up degrees. So 44.42 degrees, that's what A is. And that's complete. Now, easier to me would be to say that if I know that this is 90 degrees, and now I know that this is 44.42 degrees, how many more degrees do I need down here at B to make 180 degrees? So that's what I'm going to do first to figure out what B is, and then I'll also show you how can you use trig to figure that out too, and we should get the same thing if everything's all good. So we know that every triangle adds up to 180 degrees, so here's 90 of it. A we just found to be 44.42, and I should have B left over. So 90 plus 44.42 plus something else should be equal to the 180. Let's figure out exactly what. So 180 minus 90 minus 44.42, I'm left with 45.58. 45.58 degrees should be B. And just to show you that we could have used trig to figure that out as well, I'm going to take out my blue marker here again. Actually, I'm going to use a red one this time. Let's circle B. This is now the thing that I'm interested in. And I want to label these sides that I have, again, according to this one, though. The hypotenuse is still the hypotenuse. That doesn't really change. However, now if we look at this 10, in reference to B, it's opposite. So which one of my trig functions uses opposite and hypotenuse? All the way up here at the top, it's the sine function. Sine is opposite over hypotenuse. I want the angle out of it, so I have to undo the sine to get that theta, that angle, all alone. I undo the sine by doing the sine inverse. So let's go ahead and do that here, and I should get the same thing. I want to do the sine inverse, and this is B is going to be equal to, let me move this over a little bit. So B is going to be equal to the sine inverse of my sine ratio, which is 10 over 14. And when I do this, hopefully I'm going to get 45.58, or else I'm going to look very, very silly up here. 10 divided by 14, wouldn't you know it, 45.58, just in case you didn't believe me there. So you can use trig, or you could use this sum to 180 fact as well. I like to use the sum to 180 when I'm finding my last angle, just because to me that's so much easier than doing the trig. Although, I mean, really, they're both kind of the same in terms of difficulty. You just got to remember your ratio for trig. And now, on to the last thing. I need this last side, C. And I'm going to show you that there's also two ways that I could figure out C. Really, there's way more than two at this point, since I know some other things here. But let's just stick with the two obvious ones based on the things that I'm given. The first thing here is actually, for this side, I guess based on what I've given you, the only way to figure it out is the Pythagorean theorem. So let's start off with that. I gave you two sides of a right triangle. Find the last one. Leg, leg, hypotenuse. So we've got, I can get rid of, I've got space over here. So we can do 10 squared plus c squared equals 14 squared. Leg squared equals hypotenuse squared. Adding these together, and taking care of all our square roots, or squares rather. 14 times 14 gives me 196. So 100 plus c squared equals 196. Subtract the 100 from both sides. So c squared equals 96. Take the square root of 96, and I get 9.8 when you round. So this side, c, is 9.8. Now let's just say, hypothetically, maybe I wanted to do trig to figure that out. Well, I'm able to do that, actually, in this case, because I know these angles now. If I didn't know the angles, I'd have to find them first, because I can't really do trig with this right angle. It just doesn't work so well. I'm going to choose the A angle up here, because that's the first one that we had found, 44.42. So let's just work with that and see if we can figure out this C, and I should get the same things I got over there. So A was 44.42, C was 45.58. Right? I think so. If I remember right. I just erased it. But I need this one here. This is going to be, if I'm using A, I want C, and I have these two things, I've got two options. Either I could use the tangent, because down here, C, in reference to A, this is opposite. So I could use the opposite and then adjacent to A, that's tangent. Or I could use opposite and hypotenuse, and that would be the sine. So let me just show you with both of them. Sine of this angle, 44.42, should be equal to the opposite, which is C, divided by the hypotenuse, which is 14. So I can do 14 times sine of 44.42, and that's C. 14 times sine of 44.42, 9.8. Good to know math works. I could have also chosen to do the tangent, because I could use this side here as well. So I could do the tangent of 44.42, and that should be equal to my opposite, which is C, divided by my adjacent, which is 10. Which means 10 times tangent of 44.42 is equal to C. And if I do a check on this, 10 times tangent of 44.42, once again, it's coming up with 9.8. So, there's a lot of freedom with this, and that's one of the things that I like about it. That's one of the things that I like with math in general, is that you've just got a ton of freedom when you start to really understand what's going on to get to the same conclusion. So it all just depends, where are you most comfortable? I'm going to make another one up here, and I'm just going to solve it whatever way I kind of see fit, okay? So I'll give you an angle this time and a side, and we'll see what we can do from there. And again, I have no idea what the answers are going to be, but we'll figure them out. All right, this time, let's get a 20-degree angle on top, and I know that does not look like 20 degrees, but whatever. Let's make it over here. This one looks a lot more like 20 degrees. There we go. So 20 degrees down here, and we'll put a 12 down here on the bottom. Now the three things that I don't know, A, B, and C. Side A, angle B, and side C. To me, when I look at this, I've got a 90-degree angle and I've got a 20-degree angle. It sure is easy to figure out that last angle because they have to add up to 180. When I add all three of these angles together, I got to get 180. So 180 equals 90 plus 20 plus b. 90 and 20 makes 110. 180 minus 110 leaves me with 70 degrees. Done for B. If I find some other sides, I could have also used trig to come up with that same answer. But I think this is certainly easier. So we know B is 70 degrees. Great. It looks like I've got this angle and the side down here. I can figure out any other side using these trig functions. Let's figure out what A is based on this angle that I already know. So for my angle that I already know, down here the 12 is adjacent, and across the way to A, this is opposite, and C is always just the hypotenuse here in this case, because hypotenuse is opposite the 90 degrees. So let's find A. Opposite, and I have adjacent. Opposite and adjacent, that's my tangent. So we can do the tangent of 20 degrees, that's the angle I'm looking at, should be equal to the opposite, which is A, divided by the adjacent, which is 12. Therefore, if I multiply both sides by 12, I've got 12 tangent 20 equals A. 12 times tangent of 20 degrees gives me 4.37. 4.37. So side A over there is 4.37. And at this point now, you've got some more freedom. I could do another trig ratio, which actually I'm going to say is going to be probably the easier way in this case to figure out what C is. Or you could use the Pythagorean theorem, right? I know that this is 12, and now I know that this is 4.37. So I could just do 12 squared plus 4.37 squared equals the hypotenuse squared. Add those two things together, take the square root, and I should have my answer. I'm going to do trig for it, though, just because I think it's probably going to be a little bit quicker, at least for me. Looking again at this 20 degrees, because I know that's something that they gave me, but I could have also used the 70 up here. It doesn't matter. I'm just going to use the 20. And the other side that I know, which is the 12, and now I want the C, though. So adjacent and hypotenuse, that's cosine. So I could write the cosine of 20 degrees, in this case, is going to be equal to my adjacent, which is 12, divided by my hypotenuse, which is C. And from here, what I want to do to solve for C is I want to multiply both sides by C to get it in the numerator, and then I want to divide both sides by cosine of 20 to get it away from that C that just moved to the other side. So effectively, these two things are going to swap places, the C and the cosine of 20. So I'll get C is equal to 12 divided by cosine of 20. This is awfully similar to that worksheet where you were solving for a missing side. These two things. So let's go ahead and figure out 12 divided by cosine of 20. I'm coming up with 12.77. 12.77. C equals 12.77. And that makes sense because the hypotenuse should be the longest piece here. You could verify this as well with the Pythagorean theorem or using other trig functions. All right, I'm going to give one more example here. This time, I can't give you two angles. And if you can tell me why it doesn't make much sense for me to only give you two angles and then have you find the sides, maybe I'll give you a cookie or something. But certainly you could email me your response to that. Why could I not just give you all of these angles and then have you solve for the sides? Why does that not work out? And it does work, but it doesn't work out in terms of like a multiple choice question. See what you think about that. But I'm going to give you just another one here. I'll probably give you the hypotenuse and an angle, and we'll just work from there. see what we can do just to have another example. Pick a number from, like, I don't know, 10 to 60. 23, good choice. Good choice. Now 23 is too close to the 20 from last time. Let's do 42. 42 is a good number as well. Let's make that 42 degrees. And now we've still got three things to figure out. Let's call this side A. Let's call this side B. And this angle down here C. These are the three things that I need to know. Again, for me, looking at this, if I've got a 90-degree angle and a 42-degree angle, sure is quick to figure out that last one. 180 is equal to 90 plus 42 plus, in this case, C. 90 and 42 makes 132. How much more do I need to get to the 180? Sounds to me like about 48. So 48 degrees will be C. Now let's figure out one of these other two sides. I'm going to use the 42 as my reference angle, which means here the 16, this is my hypotenuse, always opposite the 90 degrees. B would be opposite, and A would be adjacent. I can figure out A because I'd be wanting the adjacent, and I have the hypotenuse, and I've got my angle. What trig function uses adjacent and hypotenuse? It's the cosine. So let's go with the cosine. Cosine of 42 degrees is equal to the adjacent divided by the hypotenuse. Solve for A by multiplying by 16. So I've got 16 cosine 42 is equal to A. 16 times cosine of 42, 11.89. So side A is 11.89. Side B, I'm looking at opposite, and I have the hypotenuse already. So opposite and hypotenuse, that's sine. So I can do sine of my angle, which is 42. That should be equal to the opposite, which was B, and the hypotenuse, which is 16. Which means 16 times sine of 42 is equal to B. 16 sine 42. 10.71 when you round. 10.71 equals B. Could have figured that out as well with the Pythagorean theorem, or using trig from a different reference angle, as long as it's not the 90-degree one. The options are there for you. I hope this has helped, seeing a couple of these done. It's all about your trig functions and your ratios, and knowing how to manipulate them to figure out what you want. Also, don't forget that every triangle, they have to add up to 180 degrees. It can save you a lot of heartache and like painstaking work. Not necessarily painstaking, but look at how easy this was to figure out that last angle. All right, email me. Let me know if you have any questions. The quiz will be going up probably tomorrow around midday. You'll have until the end of next week to try to finish that up. And again, next week, we're going to do law of sines. We're going to do law of cosines. I'm out.